Hello and welcome back. In number three, we're going to talk about model inversion attack. It's when an attacker tries to reverse engineer the model to extract information from it. But this is extremely important because there might be some specific information that are stored. Let's say if you had any sensitive data, let's say in healthcare or in financial department, like in bank, that they have the credit card information, or insurance company if they have any information like social security number, social insurance number. So those might be actually learned by the model. So if they can extract information from it, they can learn those sensitive information too. So let's look at some example like stealing personal information from a face recognition model. Let's say you have trained the model that can recognize faces, and attacker, if they can extract information from your model, they might recover some personal information, including the name of people, their address, their social security number. And the other one is bypassing a bot detection model. Uh, let's say if there you have the machine learning model that is detecting bots. So the advertiser trains the deep learning model for a bot detection and use it to invert the prediction of bot. So they learn the behavior of that, and they learn that wherever the advertiser input their bots into the model, and is able to make bots appear as human, allowing them to bypass the bot detection. So it's about like they can learn it, and they can, whenever you have a bot detection, because of course in advertisement you don't want a bot to click on the links, but if they do that, then they can manipulate it so you think that's coming from a human, not from a bot. So this is like submitting an image to the model and analyzing the model's response. So it's like a black box behavior. You provide an input and you look at the output behavior, and based on that, you make some conclusion. It's, of course, a reverse engineering problem. And confidential information about the input data can be compromised, the input that you provided during the training. So again, there are ways to stop this. For example, access control. Who has access uh, to the model or its prediction? Because you want to make sure that people cannot extract the information that you use during training. And input validation. For example, if a user asks the model what is the secret or what is the name of the person that was used during the training, you should validate it, and the model should actually stop it by the system prompt that the developer are using during the training. Model transparency, which means that logging all the inputs and output, providing explanation for models prediction, and allowing user to inspect the model's internal representation. So again, logs everything, logs all the inputs and outputs, and regular monitoring uh, to track the distribution of input and output, comparing the model's prediction. So you know how the model is responding to the queries of the user. And model retraining, we have to retrain the model every couple of months or maybe sooner or later. So this can be done again by incorporating new data and correcting any inaccuracy. So if you realize that there are some information that are leaking, you have to retrain your model to make sure that those information are not leaked. Of course, you can use the system prompts too, but it is quite a challenging problem because system prompts can be bypassed by carefully crafted user prompts. So have that in mind. Okay.